Welcome everyone, my name is Tim Burris, and today I want to talk about MQTT for the everyday .NET developer. If you haven't worked in the IoT industry, then this is probably your first introduction to MQTT. So what is MQTT? Well, it stands for Message Queuing Telemetry Transport, but that doesn't really say what it is. Ultimately, it's a super lightweight publish and subscribe network protocol. And this protocol has been super popular in the IoT industry because it's very lightweight and extremely efficient. Not only is it very lightweight, it has the capacity to handle tons and tons of traffic. There's a lot of benchmarking and documentation out there, but most of the brokers you could expect to handle tens or hundreds of thousands of messages per second, and most of them support hundreds or even millions of connections concurrently. So if you're thinking of using something like MQTT for, the everyday business application, I don't think you're going to need to dive into, exactly how many messages can my MQTT broker handle. I'd suffice it to say it can handle more than you're going to be able to throw at it. So in a typical MQTT kind of environment or solution, you're going to have a publisher or multiple publishers that are going to be sending messages into the broker. And then you have one or many subscribers who are going to be connected to that broker and listening for those messages that are going to come through. Now, those messages could be something as simple as an integer value, 0, 1, 2, 3, or it could be something more complicated like a JSON payload. And for business applications, a lot of time what you would want is a JSON payload. In the IoT industry, you'll see them often using it for very small pieces of data like a 0 or 1 to say that something is running or not running. But for the business world, I would expect most of the time the payload that you're going to use in your MQTT transport is going to be JSON. So I'm going to demonstrate some publish and subscribe using MQTT, which I have running here on my local machine. First, I want to call out the broker that I'm running on my machine and that I prefer to use in most scenarios is Mosquitto. I like to use the Mosquitto broker because it's free, honestly. It has two ways to install it. You can install it and run it as a service so that when you boot your machine, it's always running. So that's great when you deploy to production environments. But like how I like to run it on my machine is it also supports just running it on demand. So it's super lightweight, a little executable. You execute it, that service is running and listening. Tons of documentation out there about using Mosquitto. So now Mosquitto is simply the broker. It's just the behind the scenes guy that's receiving the incoming messages and pushing them out to everyone that's subscribed. You're still going to want a client that you can use to kind of test it, like to view the traffic that's going through your MQTT broker. And for that, I recommend MQTT Explorer. What we're going to do right now is I've run MQTT Explorer. The first thing, I'm just going to connect to localhost because that's where it's running. These are all the defaults, and this is what you would get for most of your brokers by default, that it would run localhost and that it would run on port 1883. You can definitely configure username and passwords and TLS encryption and all that stuff, but just out of the box, super simple, install it or just run the executable for your broker, and then you can run this guy and connect directly to it. So that's what we're going to do right now. In this client tool, you can both publish messages to your broker as well as receive them. So on the left side, you would see any messages that are coming in, and then over here on the right-hand side, you have an option to publish messages to your broker. Again, we're connected to localhost. In MQTT, you have this concept of topic, and you can see it by the watermark placeholder here. That example/topic. So you would see things like, if you were going to use this to publish sales order data, like every time a sales order came in, you wanted to publish that you received the sales order, or every time a sales order changed status, you wanted to publish that sales order had changed status. You might use kind of a schema, like maybe you would do the location, maybe the city, where this office is. So we'll do Walterboro, and we'll do the sales department, for example, and orders. And we would say order number 79. So this can be anything you want it to be, but you'll often see it broken out like this, and there's good reason to segment your topics because clients can then filter on them. I could choose to watch for all messages from Walterboro. I could choose to watch for all messages from Walterboro/sales. I could choose to watch for all messages from sales, regardless of the city. So by segmenting out your topics, it'll allow your clients who are watching for data to easily filter and only subscribe to the messages they care for. Now, you could always subscribe to all of them, but depending on your specific environment, maybe watching for all of them is not going to be useful. I'm going to so I've got this topic. I'm going to paste in some just a very small piece of JSON. Here we go. So this is our JSON sales order 37. It's funny, I called it 79. Doesn't matter. Order status. So when I hit publish, you'll see that my client here received this event from my broker that we received a message at Walterboro sales orders and order number 79. Again, this doesn't have to be JSON. If you wanted it to just be a number, you could just put a number in. But we'll real quickly demonstrate the power of MQTT by running a few extra clients here, and I'm going to use this guy over here on the left as just my publisher. I'm not gonna view, and then over here I'm going to have one instance that so in this client here I can choose which topics I want to subscribe to. So pound sign would mean subscribe to all topics. I'm actually going to say that this one is only going to watch for Walterboro, so only the messages that come in from any Walterboro messages. So I'll add that guy, and then also I'll need to give it a unique ID right here. So this client, this MQTT Explorer, is going to assign its individual client ID, and so a client ID can really be anything you want, but it's a way a broker will know who you are. So the important thing there is, while MQTT is not a database, it doesn't persist messages indefinitely. It can know what messages come in between when a client might have disconnected and reconnected. So let's say that this instance lost connection and 5 messages came in. By using its client ID, this specific client could reconnect, and when he reconnects, he could say, "Send me all the messages that I missed while I was offline," and that works by using this unique ID or this ID. So if it's not unique, then there would be no way for the broker to know, well, this instance versus other instances. So and each broker can only have one instance of a client ID connected. So we're gonna have to give this one its own ID. So I'm going to say I'm just going to add ABC on the end of this guy, and that'll be good. We'll connect this guy, let him run, and then so that guy is just watching for all the Walterboro messages, and then this guy again we're going to make sure he gets a different client ID so that these guys can each watch for their own messages. And I'm going to kill the main ones, and this guy will watch for everything. And so this guy's going to watch for anything in the sales segment. So we'll use the plus sign, which is a wildcard, to say we don't care about any first segment /sales/orders, and then all the orders. So this would be sales orders that come in from any of the branches, Walterboro or Isle of Tortuga, wherever it should come from. This connection will get them all. And we're not going to dive into all the wildcards here of formatting. Just know that the purpose of these topics and segmenting them is so that you can do things like this and make sure that you are getting only the information you want. You don't want to waste a bunch of time responding to messages that you don't even care about. So with that, we'll go ahead and connect this guy. So now we have both of these running. And then over here, we still have this guy that's going to be sending out messages. So I'm going to go ahead and publish this. And we'll see that this guy received one, but why didn't this guy receive it? I might have messed up his topic. Oh, maybe I didn't. I don't think I added him in. Maybe I didn't hit the add button. So we're gonna go with plus sales/orders/pound, and there we go. Let's do this, and then let's publish again and see. Yeah, so now we see it. So both of them got it. Well, and they both receive that message. Now, so if we change this to completed and we publish out again, then both of them receive the update. But if we change this to be, let's go with New York, and now only the one watching for all sales orders should receive it, because this guy is only watching for Walterboro. So we're going to publish, and sure enough, so you see this guy gets his message at sales orders. And similarly, if we were to make this a Walterboro message, but it wasn't for sales, Walterboro, and instead this was going to be for, let's say this was shipping, and this is tracking, ABC. Now this guy on the bottom should get it, because he's watching for everything from Walterboro, but this guy is only watching for sales orders. So we'll publish, and sure enough, this guy get it. Now, again, what I want to call out is, in this client, it looks like these are kind of stored in a database, but this is just the client keeping record of it. The broker receives the messages and pushes them out, and in general doesn't keep storage of them. The small caveat being, if you configure it so that when your clients reconnect, they can get the messages that they lost, then yes, it will store those messages in memory, but you shouldn't consider this like some kind of persistence layer where if the machine it goes down and reboots, or the app crashes and restarts, that data is going to be gone. So it's just a temporary storage. Think of MQTT as just events. You're just pushing those events and receiving them. You can get the ones you missed, but this is not a database. And here's a real world solution where I used MQTT as part of my .NET application or applications to solve a problem. So a company has a workstation in their office with 5 dot matrix printers hooked up to it. So the workstation has 5 dot matrix printer. Each printer is loaded with a special paper meant for printing specific things, shipping manifests, shipping labels. So these are pre-printed forms that the data just needs to be filled in on those forms. For filling out this data, there is a web server. So this would be the web server, which is running a .NET Core web application that different users use from their desk. So user 1, user 2, they both connect to this web server through the browser, and when they're ready to print, for example, let's say a hazardous shipping manifest, they're going to pull it up in their web application. They want to be able to hit print from their computer. They don't want to print on their computer. They need to print on one of these specific printers, 1 through 5, and they know which one. So how are we going to do this? Well, one way is every user in the office who might use the application could have a network printer to these five printers. Now, that seems like a logical option, one that we actually used for a while. The problem is these printers go down all the time. Dot matrix is not the most modern printer in the world, so they're often being replaced. And every time they replace it, then it's got a new it's probably a new model, so new driver. You have to set everything up, and so that means each workstation needs to have that set up on them. Now you can use domain level printers and things like that all to work around it, but it just really has not worked very well. These forms have to be printed very precisely, and every time one computer's printer driver works slightly different, one of them's on Windows 11 and one of them's on Windows 8, and it misaligns the text just a little bit. When you're printing 500 of these at a time, one small little mistake there, and now you've just wasted 500 labels that are for hazardous waste drums, and it just continued to be a problem. So how can we use MQTT? How did I use MQTT to solve this problem? What I did was I set up an MQTT broker on a server there in their server rack, and I connected the web server, the .NET Core application, to it, so that when the user hit print, he would send a message to MQTT and say, I need a list of printers. And this workstation with all the printers attached has a small .NET Core console application running on it at all times, and it is subscribed to this broker. And so anytime it receives a request that someone wants a list of printers, he checks using .NET the list of printers, and this actually should be this direction. He checks his list of printers, and then he sends a message back to MQTT to say, hey, these are my printers. And then, so that happens, and this web server who is subscribed to those messages for printer lists will receive it and can present it to the user. These are the printers that are available. The user can select one, and then he can send another message back to a different topic saying, hey, print this. And then the workstation will receive that print. He's watching for that print topic, receive it, and then he will print it. Now, of course, are there other ways to solve this without MQTT? Sure. The web server has a database. He could put an entry into the database, and the workstation could constantly be polling the database every 5 seconds, saying, "Hey, do you have anything? Hey, do you have anything? Hey, do you have anything?" But that polling, one, is just not an ideal option, and two, it means that the user could at most have a 5-second delay between the time that he asks for a list of printers and when he gets it. Actually make it a 10-second, because that means the web server would also be polling the database every 5 seconds to say, hey, have they given me the list yet? And so, that could be up to 10 seconds. You could pull that down. Maybe it's 1 second. Do you really want both applications polling the database every second? Hey, has someone posted anything? Sure. I mean, that ultimately not the worst solution, but it's not the best solution. With this MQTT broker, you get an instant response because this is super fast. You send the message, he receives it, he sends the list back, the user can move on along their merry way. So I guess my argument for this would be not should I use something other than MQTT. The question would be, well, why not use MQTT? I mean, there are other options out there. Everyone's going to have their pros and cons. I mean, I would argue that MQTT is as good as any solution for this problem. And so let's see how that would work. On the left here, we have our web application running. We've already opened up one of the labels, one of the hazardous waste labels that we might want to print. And on the right-hand side, we have our MQTT Explorer, which is hooked up to our localhost, so it'll see all the messages come through. So we should be able to see the requests for printers, and we should be able to see the agent post back, hey, these are the printers I have. So I'm going to hit the print button, and we saw the two messages come in, and it happened so fast. We didn't get to see the request and then the answer, one after the other. They both happened pretty much instantaneously, but we drilled down and we can see that the request, the printer list, came through with the date that they requested, and then we can see that another topic was sent back, was posted showing the list of printers. So you can see in this JSON payload here, if we expand this out just a little bit, that we sent back the printers that we have, and that's what we see on the screen. So then when we actually send this to print, you'll see you saw this other topic come in, and it was request to print, and this is this is just a JSON that I need to be able to print it, where each of these fields should show up on the label. So that's how it can work, where one person says, give me a printer list, the workstation responds with the printer list, and then the workstation says, well, I want you to print, and you can see here this is the printer that I selected from the web application. Now, there's actually some side benefits to just this approach in general. Originally when we were using the Windows printer dialog and shared printers, when you would hit print, you would get whatever the printer dialog is that Google Chrome gives you, or Firefox, or whatever you're using, and it's not always the most friendly. What this solution allowed me to do is actually, when I hit print for these hazardous labels, the application stores which printer the user selected and suggests that printer moving forward. So if I chose fax, the next time I printed a has label, it would recommend that I print with fax. And the reason that's important, if you remember, there's 5 printers loaded with different types of paper. And so it's going to be loaded with that type of paper indefinitely, really, until the printer breaks and goes down and they have to replace it with another one. This way, each of these 5 different forms they're trying to print, whenever the user comes in here and they hit print, it's going to recommend what they printed last time for that type of form and saves them a ton of time. And I'd like to go over one more real-world example of how I've used MQTT in a .NET application. I'm not going to dive into the whole architecture of this, but what you're seeing crazily on the screen here is my MQTT Explorer hooked up to my MQTT broker, just waiting to show us what's happening. And then over here on the left, I have 2 instances of a mapping application running. So I've got this top instance here where I can zoom in and out. I can do things on this map, and I have a second instance of the same application running here, but they work independently of each other. If I zoom in this one, it does not impact that one. But for MQTT, where it comes into play is users who are using this application are doing a lot of things. They are making a lot of changes, they're moving dots around, they're drawing things, and when those things happen, all other desktop applications, all other users who are in that same area, who are kind of observing the same geolocation, they need to see those changes instantly. And those computers not always on the same network, even in the same building, in the same state. I mean, it could be around the world. So how do we do that? Well, we use MQTT. So every time the user does something, like if I drop this dot here, then what we'll see is we'll see a bunch of messages come through our MQTT saying what happened. And if you're not familiar, or if you are familiar with MGRS, which is Military Grid Reference System, these are the locations. These are squares. The globe is made up of all these different squares. So these are just different degrees of precision saying where this event happened. And so both of these apps are connected to the same broker. So anytime this workstation does something, the other workstation will know because he'll get the event. He subscribes to these different topics because he's looking at this space on the map. And so when I drag this guy here and I move him over there, you see him move down here as well because he received the same notification, hey, something happened up there. So if I drop another guy here, boom, he's going to pop up there. And that's all happening because this bottom client is subscribing to all the messages that are in the area that he's concerned with. And so when we think back to MQTT Broker being super lightweight and supporting hundreds of thousands of connections, well, this is one of those times. This needs to be fast. We're not going to have hundreds of thousands of clients, but we might have 100. We might have 200. And so the way this works is when this user makes a change, that change goes to a REST API, says, hey, move this dot, and then that API, when he makes a change, he sends a message up to MQTT and says, hey, this just changed. This guy just did this. And so he pushes that message to MQTT, and then everyone immediately knows. And it's not super important what the content of these messages are, for this demo, but just to drill in, I mean, you can see this JSON payload includes, everything that happened, the Latin long, that the event happened, what the system says happened. And I know I mentioned MGRS way out of the scope of this, but this is an MGRS location, which you can translate any lat long to a military grid reference system. And so different levels of precision here get more fine-grained into the location. So if you watch for 17S, that would be a really big square that encompasses all of Walterboro and surrounding areas, and you keep drilling down to all the way to 17S, NS 3039, and now you're starting to get down to a much smaller square. So depending on your zoom level of this application, if you're zoomed way in or way out, you need to watch for different buckets of calls. So when the API receives this message, he breaks it down and, based on configuration and other things, decides, well, what granularity should we publish these messages. You publish the same event to all these different topics. That way, people who are watching at different precision levels can receive it. Or maybe they're not concerned with the location of it. Maybe they are concerned with the name of this location here, which is Walterboro. So you could just watch for everything in there, or you could just watch for all the things for this type of object. Let's say we dropped a camera, a video sensor on here, 3 of them in fact. You might maybe you're concerned with video sensors, and so you could just subscribe to this video sensor topic, and anytime any video sensor around the world was adjusted by a user, then you would receive that notification. So when you're thinking about your MQTT broker, it's not like you just need to publish to one topic. Get creative and publish your events to all the different topics that will allow your connected clients to filter down to only what they need. Now, when it comes to actually coding your MQTT into your application, I'll probably do in depth in a different video where I actually write it. But I mean, honestly, the reason is it's quite trivial. This MQTT net is a NuGet package. It's here on GitHub, not mine, and it provides everything that you need to connect to an MQTT broker from .NET, send messages, and subscribe to messages. So, this will do it all. It actually also has an MQTT broker built in, but I actually haven't used that. So I've only used this to actually connect. Again, I usually use Mosquitto, but this lets you connect. And, it's fully documented. So the actual act of connecting is pretty straightforward. You would you create your instance here. You connect to your TCP server. This would be where your broker is, localhost if you're running on your machine. User password, just put it in plain text. It should be fine. Set up your TLS passwords and SSL certificates, all this kind of jazz. If you're doing all of that, it's all in here. And then once you've set up your SSL, then simple code to again just to connect. And here's talks about reconnecting if you lose connection. And it's interesting, they put consuming the messages, like receiving your message here from your client. They put that before they talk about actually subscribing to a topic to receive that message. But point being, you would say you're going to subscribe to, again, and this is that topic kind of nomenclature that we talked about, where you could use pounds and plus and different wildcards to choose which topics you want to subscribe to. So you would subscribe, and then when a message comes in, this would fire. And in this particular example, it looks like they receive the message and then they push out, they publish another message. So, and again, maybe I'll do another video where I code it from scratch, but I think you can probably get started with this. The last thing that I want to say about using MQTT, or one of the advantages that I think I failed to mention, which is that this is an open architecture. This is a published protocol. This isn't you developing your own way to do publish and subscribe. And some benefits to that are that MQTT is quite widely used in the automation community. So, if you have an application that's publishing MQTT, then you can make use of things like N8N. If you're not familiar with N8N, it's an automation tool. It's free, open source, and it's kind of what you would expect. You respond, you receive events, and then you do things like send a Slack message or send something to Google Sheets you can see on their site. But the important part here is they support MQTT. So here they're talking about a webhook, but you could have that be connected to your MQTT broker, and when it receives it, you could check the message. Maybe you check the content of that MQTT, parse the JSON, and then based on that, maybe you send an email or post a Slack message. But N8N, Node-RED, there's plenty of automation frameworks out there, and most of them will support MQTT as a way to trigger events. alternatively, you could even use one of these automation frameworks to push notices to MQTT, and then you could receive it from .NET. So by not building your own homegrown publish and subscribe, where maybe you push it to a database and you just keep checking, you allow yourself to take advantage of some of these other tools where maybe you don't have to build everything yourself. Maybe you could, maybe you have a power user who can come and build some of these workflows that do things based on the messages that you're pushing into your MQTT broker. And with that, I think that's everything that I have on MQTT. I hope that you learned a little bit about MQTT, and maybe this video kind of got your mind churning a bit about how it might be able to help you in a current project or a future project. As always, I appreciate you taking the time to listen to me. Have a wonderful day.